morning. Our focus in this video is in Module 5 and 6 rather than Module 7 and 8, where most of the videos have come from. I wanted to take some time to talk about intervals of increase and decrease and extrema, that is the minimums and maximums. So extrema are minimums and maximums within the graph. And when we talk about extrema, we're referring to the output values and the input values that produce them. But it is actually the output value that we're most concerned with. For example, if I look at this graph of I've named it g of x. It's a polynomial for x to the fourth plus 3x cubed minus 2x plus 1. There are several extrema here. Here's a minimum, a maximum, and another minimum. And these values have different kinds of, there are different kinds of extrema. So these are all extrema. But for example, the value at the bottom here, this negative 2.141 comma negative 3.148, this is an absolute minimum, which means it is the lowest output produced by this function. And it's produced at negative 2.141. In fact, let's snip this over into our PowerPoint so that we can write on it. Let's see here. Okay, let's take this guy right here and put it over here in our PowerPoint so that we can take a look at it. Let's shrink it down. Okay, so in this particular, well, that was weird. In this particular image, what we're looking for is that this point here is an absolute maximum, excuse me, absolute minimum. We could say that G of negative 2.141 produces an absolute minimum output of negative 3.148. On the other hand, we have here a local minimum, and here a local maximum. In general, a minimum, let's just write this down. So a minimum value is identified by increasing outputs to the left and decreasing outputs to the right. On the other hand, a maximum value is identified by decreasing outputs to the left and increasing outputs to the right. So we can see that here that we are decreasing to the left, and then we begin increasing, making this point here a minimum. On the other hand, we are increasing. Well, I said those wrong, didn't I? I'm sorry. Let's switch those. So we'll fix that. So a maximum value is identified by increasing outputs to the left, so we're increasing to the point, and then decreasing outputs to the right, so we're decreasing away from the point. A minimum value is identified by decreasing outputs to the left, in other words, as we approach, and increasing outputs to the right as we leave. And a local minimum or maximum carries the characteristics above, but there are other more extreme minimums or maximums on the graph. We could say even produced by the function. whereas an absolute minimum or maximum, for an absolute minimum or maximum, there are no other more extreme minimums or maximums produced by the function. We'll say minimum or maximum output produced by the function. So this point that I've circled down here gives us an absolute minimum. The other two, while we do have an increasing to decreasing and then decreasing to increasing, we have a local maximum and a local minimum there. We can see that also in this graph. Whoopsie, wrong one. In this graph, we have a rational function here, f of x, and you can see that we are going to increase up to some point. There it is. And we're going to have a minimum there, but these values are both local maximum, local minimum. And we know that because if we look to the right over here, there are many values that are more extremely maximum outputs than this 1.5, 6. And there are also many more smaller or more minimum outputs than this 2.5, 8. So this is a local maximum, this is a local minimum. All right. So when we talk about intervals of increasing and decreasing, we're looking for those intervals between the maximums and minimums that give us that information. In fact, let's duplicate this slide. We'll duplicate this one. And we'll go up here and we'll name this increasing and decreasing. And in particular, we're looking for intervals in fact, let's be specific. Input intervals along which the outputs decrease or increase. Generally, we can look for these intervals between extrema, although not always. It's a good starting place. Let's see what we're talking about here. Let's take that rational function and let's take a look at it real quick. Let's pull it over into the PowerPoint. So we will snip it. Okay. Now in this particular case, we have an asymptote at we have an asymptote here at x equal 2. We have a local minimum at 2.5, 8. Right here we have a local min. Here we have a local max. And so we have an interval of increase see here. We have an interval of increase that goes from negative infinity, let's find our infinity symbol, all the way to 1.5, because this is an input interval. So we're looking at the inputs that make this happen. We also have an interval of decrease right after that that goes from 1.5, to 2, right? Now it's not going to include 2 because 2 is an asymptote, but intervals of increase and decrease don't tend to include their endpoints because generally their endpoints are a local maximum, local minimum, extrema, those kinds of things. And so at that point, we're neither decreasing nor increasing, so it's not going to be included in those. But if we look on the other side of the asymptote, we have another interval of decrease. So let's union that with this other interval of decrease, which is going to go from 2 to 2.5. So in this interval right here, we're decreasing. And in this interval, we are also decreasing. So we've got 2 intervals of decrease. Likewise, we have 2 intervals of increase. We have the one from negative infinity to 1.5, but we also have one from 2.5 to positive infinity. So we have 2.5 to positive infinity. Okay, so there's our two intervals of increase and decrease, and so that's how we would answer that part of test 4. If we wanted to do something similar with the problem from the previous slide, let's pull that over. Let's see here, it's right here. So let's pull this guy in, copy. Let's paste him in here. If we wanted to look at the intervals of increase and decrease here, let's take a look. So we're going to take our stuff here. So intervals of increase. Okay, well, we've got one here. We've got another one here. Those local extrema and the absolute extrema are going to help us to think about that. So let's put those in. So from negative 2.141 to negative 0.541, so these are approximations, of course, unioned with from 0.432 all the way to infinity. Okay. And likewise, we've got some intervals of decrease. And those would be, let's see here, we'll change colors real quick. So those would be here and then here, right? We've got those two intervals of decrease. So let's go in and put that in. So we've got from negative infinity to negative 2.141, and from negative 0.541 to 0.432. Notice that all of these numbers that I've typed on this page, every single one of the numbers I've typed on this page, represent an input value and not an output value. So when we look at extrema, we're looking for the input value that creates that maximum or minimum output value. But when we're looking for increasing and decreasing, we're looking for the interval of input values over which there is an increase or decrease in the output values. And that can be a little bit sticky sometimes. So think about that verbiage and think about how you want to be able to write that out on your module 5 and 6 test for test 4. Okay, and that does it for intervals of increase and decrease and extrema.